So this is lesson 15 in Algebra 2, and it's called elimination. And again, let's do a little bit of review. I think it was lesson 13 where we did the substitution method. And again, this is called a system of equations. It's two equations, and we have two variables. When you have two equations and two variables, you can find the answer. If any of that changes, you cannot find the answer. If we only have one equation and two variables, we can't find the answer. So this gives us a chance to find out what both the x value and y value equal. And substitution says if we can set one of the equations equal to a variable, then whenever we see that variable in the other equation, we can substitute. So instead of an x in there, I can now put a y plus 1. And then I leave the 2y there, and I did a couple things here. By substituting y plus 1 in for x, I've given one equation and one variable. That's the only way I can solve these, is when I get down to one variable. And then I just did my distributive property, combine like terms, etc., and I'm able to find y. And then once I find what number y equals, I can take it and put it back in one of my original equations and find out the x value. So that's what we did back in, I think it was lesson 13. Well, in this lesson, we are taking the same kind of problems, only instead of using substitution, we're going to use the elimination method. So, for instance, if we have an equation like 2x plus y, and we say that equals 11, and we have 3x minus 2y, and we say that equals 6. So here's my system of equations, and I'm trying to solve for both x and y. So what I'm going to do with the elimination method is I'm going to add or subtract my equations to each other. So let's say that I add my 2x and 3x, and I get 5x, and I add my y plus negative 2y, and I get negative 1y, and that equals 17. Okay, so here's what I've got. I've got two variables and one equation in my answer. That means that I cannot solve for my variables because there's only one equation. That did not take me anywhere when I did that. So there's got to be another way. I've got to be able to get rid of one of these variables so that I'm only going to have one equation with one variable. So I'm going to write this equation over here one more time. Oops. Plus y equals 11, and this is going to be 3x minus 2y equals 6. Alright, so the only way I can get rid of the x or the y is for one of those to turn into a 0. Well, the only way I can turn those into a 0 is if I say y minus y, or 3y minus 3y. You know, so if I take the same quantity away from what I'm given. So what I'm going to do is I am going to multiply this top equation by whatever is necessary to make this y a negative or a positive 2y, so that when I take 2y plus negative 2y or 2y minus 2y, these will cancel out and give me 0. I could also find out a way to make this 2 into a 3, but what times 2 is 3? You can't. Or what times 3 is 2? So these I'm not going to mess with because those are too hard to do. They can be done, but it's too much of a pain right now. We'll do it later. So I'm going to try to make this y into a 2y. So if I multiply this entire equation by 2, this top equation then will turn into 4x plus 2y equals 22. So remember the rule. I can multiply these terms, as long as I multiply them by the same number, they still equal each other. So I just multiplied them by 2, and I've got my 2y here, and on my bottom I still have 3x minus 2y equals 6. Nothing changed there. Now I'm going to add these. 4 plus 3 is 7x. 2 plus negative 2y is 0 equals 22 plus 6 is 28. Divide by 7, my x equals 4. So now that I found that my x equals 4, I can take that x equals 4 and plug it into one of these other equations. It doesn't matter which one. I usually pick the easiest one. So 2 times 4 plus y equals 11. So 8 plus y equals 11. Subtract 8, subtract 8. So y equals 3. So y equals 3 and x equals 4 when I go through this process and figure out what my x and y values are. Okay, so ready for some more. Okay, this is example 15.1. This is a little bit trickier because if you look here, there's really no way. I can't change this 3 into a 2 or the 2 into a 3 or this 2 into a 3 or this 3 into 2. I can't do anything here. So I'm kind of stuck. So what I'm going to have to do is look for greatest common factor. What is the least common multiple? What is the smallest number that both 3 and 2 go into? 6. So if I can change this to a 6 and this to a negative 6, I can take 6x minus 6x and get 0. Or if I change this to a 6 and this to a 6, I can make it 0. But let's just multiply the top number. I want to make it into a 6, so I'm going to multiply it by everything on top by 2, because that 2 times 3 will give me my 6. And we're going to multiply the bottom number by a 3, because a 3 times negative 2 is negative 6. So on the top I would get 6x plus 4y equals 46. Don't forget to multiply the 2 by everything. And then on the bottom, negative 6x plus 9y equals 6. Alright, so let's add those. 6 plus negative 6, or 6 minus 6 is 0, so those go away. 4 plus 9 is 13y equals 46 plus 6 is 52. Divide by 13, and y equals 4. So my y value equals 4. Now I'm going to take any of these problems up here. It doesn't matter if it's this one, this one, this one, or this one. I'm just going to plug 4 in. So let's take the top one. 3x plus 2 times 4 equals 23. 3x plus 8 equals 23. Subtract 8, subtract 8. 3x equals 15, so divide by 3, x equals 5. So when x equals 5, y equals 4. Okay, so that's just some basics on elimination. We'll get into some more in-depth elimination later on, but that's it for lesson 15.